not behaving.
Wait, I have a question.
Oh, really?
Yes, Sarah, she has a question. Shh.
Anything you do on there shows up on the video?
Okay, everything that I do that actually shows up on my computer screen. So, for instance, one of the classes yesterday, I moved this, and it showed up like Keystone or something on the screen, but that was because that was coming from the projector. That doesn't show up. Basically, this is recording everything that is on my actual computer screen. When I write with my slate, it's actually acting like a wireless mouse. What it's actually doing is actually sending a message to my computer, and then you're seeing it up there because it's projected. Okay, so for number 14, you have to actually try each of these transformations. Okay, and you will find that B, a rotation of 180 degrees, would map this figure onto itself, or a reflection across the y-axis followed by a reflection across the x-axis. The best advice I can give for problems like this is to actually try to do it. Okay? So one of the things that happened yesterday when I was doing this with fourth period, which is why I cannot use their video, is we were then going to review the rules for rotation. I think it was rotations we were reviewing. And they all just kept yelling stuff out. It was like, oh, it's yx, negative y, negative x, negative this, and this, that. So I want to go through with you in the video, but it is also on page 591, your rules. When we first did them, I used A, B. I'm going to use x, y. So does anybody know, and do they really know, not guess know, if I have a rotation 90 degrees, what is the rule now? Okay, negative BA, which is, if I'm using XY, negative Y, X. That's for a 90-degree rotation. All of these are counterclockwise. What's 180-degree rotation? XY becomes what? Not YX, it's actually negative X, negative Y. And a rotation of 270 degrees counterclockwise becomes Y, negative X. Okay? So you may want to jot these down. This is one of those things that when you're reviewing, like the night before, and you're like, oh my goodness, Mrs. Falk, what do I review? I would put that on the list. I'm actually going to start trying to make a list over here of some of the stuff we're coming across. We started this last week, but I would know the rotation rules. And they're all counterclockwise. And I'll put them over here. 90-degree rotation became what? 90 rotation became negative YX. 180-degree rotation. And a 270-degree counterclockwise rotation became Y negative X. Okay? I don't know if you recall when I taught you this. Okay? I said I don't use the rules when I do it personally. I just know that each quadrant I move, the order of the number flip-flops. And then I use the negative or positive signs based upon what quadrant I'm in. So for instance, when I'm going from, actually let me do point A, and that's negative, oh I don't want ones that are the same, let's do point B, negative 3, 7. I know when I move to this quadrant, I'm going to have a 7 and a 3. And this quadrant, I'm going to have a 3 and a 7. And this quadrant, I'm going to have a 7 and a 3. And then I just put the signs accordingly. So if I ended up over here and I said, I know I'm going to have a 7 and a 3, I put those down, and then I say, oh, well, in that quadrant, quadrant 3, both of them are negative. To me, I will forget these rules. Hence why even when I started doing this, even though I went through them yesterday, I'd open up the book again to page 591. I know a lot of you said you like the rules, and that's great, but you have to remember the rules. You also have to remember these are all counterclockwise. So a clockwise rotation of 90 would be the same as 270 counterclockwise, correct? Tyler, you had a question?
Let's say like the coordinates are 1, -2.
Okay.
Then if you were putting it for a 90-degree rotation, it would be would it be -2?
Okay, so the way I did it, the way I do it, you're saying, or using the rules?
Using the
Okay, so 1, -2 is what you're saying, and then the rule is -yx. So -y really means the opposite of y. So the opposite of y is 2. And then the x stays the same. Okay? Negative sign also means opposite in the way that -2 would be +2. Are we okay with this one now? You will have a lot of questions on transformations. Okay? Triangle ABC has vertices of these. And the triangle will be reflected over the x-axis, then rotated 180 degrees from the origin. I actually believe that if you check all of these, none of them are actually right. Okay? Yeah. Okay. I did it by only dealing with A, and I'm going to go through that. And when you do it, A, I think, is -1, 2. I think that's what it was. So it's, yeah, A, when we do A, is -1, 2, but the B prime doesn't work. Okay, so actually none of these are correct. If you had this on the EOC, then we'll complain about it, and you'll say, no, they kind of catch these things. They're really pretty good about this. So, because what I did was I just started with A. The triangle is reflected over the x-axis, then rotate 180 degrees. So it's 1, 2. Literally, when I do them, I draw a little diagram. That dot is at 1, 2. So if I reflect it over the x-axis, I'm going to be at 1, -2, correct? And then I rotate it at 180 degrees. Okay? So if I rotate, okay, I'm going to be back to the same x and y. But since it's -x, -y, the 1 was positive, it becomes negative. The 2 is negative, it becomes positive. So right away, the only possible answer that works is C. The problem is when you do this, the B prime of -4, -6 does not work. So this is unfortunately a bad question. Okay? Moving on to number 16. I love these drones. I don't know why, I just think they're great. Anybody else love them?
Yeah.
Oh, yay! Why is this not scrolling, though? Oh, because it's not a... What? Any idea why this is not scrolling? You think because I'm on the writing tool? That shouldn't make a difference. But we'll try. Ah! Just slow. Okay, the drone is flying at a speed of 13 meters per second in the direction towards the fire. Suppose the altitude of the UAV is now 800 meters. That means it's 800 meters above the ground. We want to know how many minutes to the nearest tenth it will be till the drone is over the fire. So the first thing we need to do is we need to figure out the distance it has to fly, right? That's A to D. After that, we're going to have to do some conversions because they want the time it's going to take. And this is meters per second. Okay? So let's figure this out, by the way. If it's 13 meters per second, and we want to know how long it's going to take in minutes, how many meters is that per minute? What's 13 times 60? Is it 780?
Yeah.
Okay, I'm going with Camelia. She's wrong, we'll blame her. Okay, she's like, I'm not wrong this fall. I know. Okay.
No, I might be wrong. It's 780.
Shut up! she's been vindicated by the calculator. Okay, so. No, she used the tools available at her disposal. So, we need to find this distance. They give you this angle, which is 30. So you need to know that the angle in the triangle there would be 60, correct? Are we finding the side that is opposite, adjacent, or the hypotenuse?
Adjacent.
We're actually finding opposite. AD is opposite the 60-degree angle. Okay? And this is adjacent. So we're going to find the opposite side length. The adjacent is 800. So we're dealing with the tangent of 60. Now in this one, you're going to actually have to find the tangent of 60. Somebody in one of the classes, I don't know if it was this one, but one of them yesterday said, Mrs. Falk, I don't remember what to do when we set these up. So it's 60 tangent, and I'm just going to leave that in the calculator times 800, and I get 1,385.64. Okay? I'm going to take that number and divide it by 780. Because that's how many meters the drone's gonna fly in a minute, correct? And I think you actually get like 1.77 in the calculator. What do we actually get in the calculator up there? 1,385. 1.77, right?
1.732. I got 1.77.
You got 1.77. Yeah, it's 1.77. You pressed something wrong. Which rounds to 1.8. Okay? Okay, partitions. For those of you who love following me on Snapchat, you'll see that last night I posted I love Snapchat. I posted the partition formulas and the formula for the equation, standard equation of a circle, on my story because I was getting people Snapchatting me all night long. Ms. Falk, what's the partition formula again? Yes.
How many questions on the EOC around partition?
Last year, although I wouldn't know for sure because nobody would have counted and told me, 3. Okay? So, but nobody would have counted and told me, right? Okay, so, guys, few things. The partition formula. So let's talk about the formula.
Am I like the only person who does not have Snapchat?
Maybe.
No.
Okay. So, for the partition formula, you do it for x and for y. So for x, that x by itself means that's going to be the x coordinate at whatever point you're finding that partitions, that breaks the segment. You take the first coordinate plus k is the ratio written as a fraction. 1 to 3 means there's one part to one side and 3 to the other. That's a total of 4 segments. So the ratio here would be 1 to 4. Okay? x2 is the x sub 2 is the x value of your second coordinate minus the x value of your first coordinate. Normally when we do these, your first coordinate is whichever one they gave you first. So if they're saying line segment JK, we're imagining that we're on point J headed to K. I want to go basically 1/4 of the distance. Okay? When they say which ones would split it into the same ratio, well, if I started from K and went 1/4 of the way. So there's a few different ways you can do this. You could actually plug the coordinates into the formula with your K ratio of 1/4 and find the coordinate for x. Then you would do the same thing for the y value. Okay? And you would find your point, which is ordered pair -1/8 when you do that. Now to find the other one, what I would do is just make the second coordinate your sub 1 and the first coordinate your sub 2. Okay? The other thing you can do, if you just totally blank out, you forget the formula, here's basically what you're saying. You're going, let's look at the x values. You're going from -4 to 8, correct? And the x value. That's a total of how many spaces? 12. Okay? You want to go 1/4 of the distance, correct? What is 1/4 of 12? How many spaces? 3. So basically you start at -4 and you add 3 because you're going towards positive land, right? So your x value is -1. Now for your y value, you're going from 11 to -1. Now this is just coincidence. It's not always the same for x and y, but this one is also 12 spaces, right? So when you go 1/4 of the way, you've gone 3 spaces. The only thing you need to get here is, in this case, you're going to subtract, only because to get from 11 to -1, you'd have to subtract. You'd have to basically think of it as you're going backwards on a number line. And 11 minus 3 is 8. That's what the partition formula is doing. The partition formula is saying, what's the distance you have to go? Hold on a second. The partition formula is actually saying, what's the total distance you have to go? That's why you're subtracting. You're going to multiply that by the ratio, how far you need to go. So we did 12, right? Multiplied by 1/4 was 3. And we just took where we were starting from and added 3. Or for the y value over here, if you do the math, you get a negative, because to go from 11 to -1, you're not going forward 12 spaces, you're going backward 12 spaces, and 1/4 of -12 is -3. Yes?
I'm saying if I can have my phone here.
Sure, you can charge your phone. No problem. Okay? And then when you do it the other way, with the other points, you get 5, -5, 2. Okay? What? This is if you started here. So here, think about it this way. If you started at 8 and you went to -4, you moved 3 spaces, right? But you moved 3 spaces backwards. Okay? Guys, if I stand at this wall, that's all you're doing. And I want to walk towards that wall, and I go 1/4 of the way, I'm adding up over here, right? If I start at this wall, I know, isn't this sorry that this isn't in the video? Picture Mrs. Falk walking across the room. If I start at this wall, and I walk 1/4 of the way, I'm like over by here somewhere, right? I walked 1/4 of the distance in between 2 walls, but it's 2 different spaces. Just like if you go from home to school, okay? If you leave home and come to school in the morning and realize you forgot your homework, hopefully you realize you forgot your homework when you were closer to home than closer to school, right? Because if you're in the driveway, your parents might be annoyed that you have to run back in the house and get your homework, but it's like, okay. If you're like, pulling into the parking lot of school, then you're like, man, why couldn't you have remember this when we were at home? Make sense?
What do you do for 3?
What? 3 because the total distance here happens to be 12, right? And what is 1/4 of 12?
No, but why do you, what do you do?
Yeah, where'd you get the 1/4?
The ratio is 1 to 3. That means you're going to a point. Technically it means you're breaking a point. Because when I'm standing right here, there's there's one section to one side of me and 3 to the other.
I never even knew you were supposed to use the partition formula. Because I always just did the other way.
And you can do the other way. Either one works, yes.
Does it just work like that? That 1 plus 3 is 4, or is it always like that?
No, if it was 1 to 5, then 1 plus 5 would be 6, then you would want 1/6 of the way.
Oh, so it's always
So it's
like
always
that.
like that.
That always are taking, okay, so that's okay. We did this when we did partitions, but I know we did it earlier in the year. The ratio, the K, is the top number and the total of, hold on a second, Tyler, the 2 sections added together. And I'm going to go on record and say you guys are such a better group than 4th period. Yes, Tyler.
You told me once that there was a rule where it said if it spells out 2, or if it spells out like.
Oh, okay. I know what you're talking about. Okay, so here was Tyler's question. If they said that parts it into something 2/3 of the way. Okay, if it actually, that's 2/3. If I were to actually write this in words, the words would be into. What would be the point that partitions this so that your 1/4 of the way would be 1/4? The ratio means 1 on one side, 3 on the other, which is 1 out of 4.
So the K was 1/3 or
1/4. Your K ratio here would be 1/4.
Wait, so wouldn't 2/3 of the way be 2/1?
Yes,
Yeah, 2.
2/3 as a ratio would be 2 to 1. So if it had 2 to 1, your K factor would be 2/3. But if it said 2/3 of the way, it'd be 2/3. I think this confusion comes from the fact, and I hate it, that when you guys first start fractions, way back in like 2nd and 3rd grade, they use ratios to represent fractions. And they tell you that 3 to 4 is 3/4. It's not. It's 3/7. Okay? Kind of like, that's the problem. Kind of like in 2nd grade, I've said it before, when they said you can't subtract 4 from 3 because 4 is bigger, but you can. It's -1. Yeah, one of these days I'm going to like revolutionize elementary school math. Not really, but it's a nice idea. We don't simplify ratios until you turn into a fraction. Don't even guys, I would not, if you had something that said 6 to 8, turn that to 6 to 14 and then simplify it. Okay? Don't try simplifying it like this.
If you did, would it mess it up?
Yeah. Okay, are we ready to move on to 18? If you still have questions on partitions, I want to answer them, but if not, I want to move on to 18. Quadrilateral mark will be reflected across the x-axis and rotated 90 degrees clockwise about the origin. So I make a little drawing. -3, 7 is going to be up there roughly, right? But at least I have it in the correct quadrant now. It's going to be reflected across the x-axis, which means it's going to be at -3, -7, correct? And then it's going to be rotated 90 degrees clockwise. A 90-degree clockwise rotation is, if we're using a rule, what rule do we use? 90 degrees clockwise, what rule do we use? Not negative BA, Tyler. We use what?
270
The
degrees.
rule for 270 counterclockwise. Okay, Tyler, you gave me the rule for 90 counterclockwise. Okay, so just make sure you remember that those rules are for counterclockwise. Okay? Now, personally, what I do is I would say 90 clockwise is going to end up back in this quadrant, right? But I know that every time I switch quadrants, my digits flip-flop. So I would know that I'm dealing with 7 and 3. And if I'm in quadrant 2, that's -7, +3. That's how I would do it. If you're using the rules, you're using the rule for a 270-degree rotation, which is y -x. They only want the y coordinate. So -3 is your x value. The opposite of x is +3. So you can do it with the rules. You can do it with hopping around quadrants. Okay? Yes?
Switching, is that points of rotation?
Yeah, rotation at the origin, going from quadrants. Right? Okay, yes. Hold on, you're taking a momentary pause because Alan needs me to look at something.
Straight, Mark. Straight.
Here to there, like the slope, okay. That works, and it's actually more. Okay? You're like designing the building. Okay? Okay, we are back. Can we get back to problem 19? Okay, what did I say about problem 19? Did I talk to you? It's, yeah, what is the problem with 19?
It's not dilated at the origin.
Right, you're not going to be asked to find something where, like it explicitly says in the standards, if you're dilating, it will tell you the point of dilation. You are not going to have to figure out the point of dilation. Okay? Number 20. They are asking you which statements would prove line R and P are perpendicular. That means you need angles that have sides of line R and line P. If angle 2 is 90 degrees, you are not proving that RP is a right angle, you are proving that NP is a right angle. Okay? If NP is a right angle, then RP definitely isn't, correct?
Yeah.
So that's not correct. If angle 6 is a 90-degree angle, then you are proving that RP creates one 90-degree angle, meaning it creates 4 90-degree angles and they're perpendicular, correct?
How come C won't be?
Yeah.
Okay, so measure of 3. Okay, here's the thing. Go back, erase what you just decided. If 3 and 6 are congruent, that doesn't mean that these, you can think of this. I can draw any set of vertical angles that are congruent. Vertical angles aren't necessarily right angles.
Yeah.
Now,
So you could go without based on what you just decided.
what?
You can't use prior information.
If they told you that 6 was a 90-degree angle, then 3 is also a 90-degree angle. But not if you started with that. I think what's happening there is you're thinking, well, this is a 90-degree angle. This is not a proof. These are each independent factors. If 6 is a 90-degree angle, well, then yes, then 3 is a 90-degree angle. But forget about that. If I just tell you that 3 and 6 are congruent, does that mean you can have lots of vertical angles that are congruent that are not 90 degrees. 1 plus 6. If 1 plus 6 are congruent, are 90, then all you're proving is N and P are perpendicular, not R and P. 3 and 4. If 3 plus 4, measure of angle 3 plus measure of angle 4 add up to form a right angle, then you're creating a right angle at the intersection of P and R are perpendicular. But if 4 and 5 are 90 degrees, then you are creating a right angle. Oh wait, is that one right also?
Yeah. No, it's
Oh, I messed up. Okay, I messed up. Sorry, hold on. I screwed up. Oh, Mrs. Falk, that's so exciting. You're not perfect. Not even close. Sorry. 3 and 4, are the intersection of P and N. 4 and 5 create a right angle for line P and line R. We okay there? There's starting to be some chatter between you guys. If you have a question, ask me. If you don't want to participate, go lay in a beanbag at the back of the room. Okay? But choose wisely. I'm begging you. Do you know why? Because your grade on this EOC means way more to me than it does to Alexandra Hamlin.
Well, what if I'm just super smart?
That's okay. I'm not upset. He knows he's getting a 5. He has it all under control. Or he's protesting me. I'm not sure which one. Yes, Alan.
Or is just tired of one prodigy?
What? Yes. Yes. What? You know what? I'm gonna leave that up to him. All right.
What if we all focus?
Then I will not be here next year.
Oh, dang.
Okay? If you all fail it, I will not be here next year. Have fun with algebra 2.
Wait, but if we all fail, we still pass them,
Yes, Alan. If you all don't get a passing score, you still pass geometry. That's why your grade on this EOC means way more to me than it does to you. If you all do badly, I will quit because I will say I was an ineffective teacher. I mean, I joke about like, oh, that's why they say I suck. I'm sorry. I think I'm really fucking awesome. I think I'm like one of the best math teachers you're ever going to have. I have a few people who don't agree. They're entitled to their opinion, okay? And Pinocchio's nose grew, and you can live in the land of Egypt, otherwise known as the land of denial, and that's fine. But honestly, at the end of the day, I have a pretty high self-esteem in terms of I know I'm a damn good teacher. Okay? I just need y'all to help me prove it's the world. Okay, but seriously, if I ever got to the point that I really felt like my students were not learning or I was not doing my job, then I would quit. Because the reality is, if I don't teach you if you have me for geometry and I don't teach you geometry, it's not like somebody else is going to. It's not like, I hate to say it, if you have a bad 9th grade freshman English teacher and you get a good 10th grade freshman sophomore English teacher, they can make up for it, right? You didn't learn that much writing or reading, you can make up for it. Math doesn't work that way, okay? Especially when you get to like geometry. Like it's not like, at least algebra 2, maybe they'll review a little algebra 1, but they're still more standalone. I digress, I'm moving on. Point P is the center of a circle. AC is the diameter. And D is a point on the circle. We had a problem like this yesterday. Just draw something. Okay? Now, AD is greater than CD. First of all, there's an issue there. I'm not sure if they're talking about a line segment. Maybe they're talking about chords. But the length of AD and CD is going to change based upon where I put this point D, correct? So that cannot be it. Okay? Measure of angle CBD. Okay? Compared to CAD. Okay. So even though it doesn't really depend, because what you have now is you have a central angle and an inscribed angle that intersect the same arc, correct? So they're going to change, but at least in that case, they'll all change basically at the same way. If CBD gets larger, so if I moved point D, let's say, over to here, and it got wider, well, then angle CAD would get wider also. Okay? So if CBD is X, would that be half of this? Well, look at them. Which one looks smaller? Angle A looks smaller, right? And if you remember, if I have a central angle and an arc, the arc is the same as the central angle, correct? If I have an inscribed angle and an arc, the arc is 2 times the inscribed angle. So this one should be larger than this one. In fact, if this is X, this should be 2 times this. Okay? I'm going to jump down. That's why D is the correct answer. Okay? They're talking about with ABD. With ABD, they're talking about a central angle, and ACD. But this, you're going to need 2 of these to make one of those. Okay, so Jason, you're going to remember this for me, right? For next year. So somebody explain to Jason the relationship between a central angle and an inscribed angle in a circle, because Jason will be sitting where you are sitting in 365 days, getting ready for his Geometry EOC, and he's going to remember this moment, right, Jason?
Sure.
So somebody tell him what's going on here.
An inscribed angle is half of the central angle.
The inscribed angle and the central angle, provided they intersect the same arc.
Okay.
The central angle is twice the inscribed angle, or the inscribed angle is 1/2 of the central angle.
Okay.
Okay, so Jason, when we get to chapter 10 next year, you can be like, Mrs. Falk, I remember learning about central angles and inscribed angles. And all the other students will either go, woo, and they'll be like, why you remember that? Thank you, Jason. You can put the computer away. See, I've had enough of you. It's time for me to start having fun with my new students. Jason, that's assuming they do okay, because if they all bomb this on purpose, I'm quitting.
I like your energy.
Okay.
Okay. Shh. We have a few more minutes. It's the Tyler special. Right, Tyler? Okay. So. Okay, guys. Yes. Oh. Back up. I didn't finish. I just found out. Shh. I did not finish problem 21. I jumped around and I didn't go back and finish it. For 20, they also had C as a correct answer. Here's the reason why. Remember that if you have a diameter of a circle and an angle is created, okay, that that angle D must be 90 degrees. I'm inscribing a triangle in a circle, and if one of the legs is the diameter, then it's also the hypotenuse of a right triangle. Okay, did I finish that problem now? Okay, come on, I think we have 3 minutes. I think we can get through the Tyler special. So, because he emailed me about it. So, guys, you do not know how to rotate around a point other than 0, 0. You didn't learn rules for it. We're not doing it right now. Okay? But you should know that when you do any rotation, it's an isometry, meaning it's still congruent. So the perimeter and the area of the new figure won't change. The measure of angle B compared to the measure of angle B prime won't change. The measure of the lengths of any of the segments won't change. The coordinates will change unless one of the coordinates is the point of rotation. So on this one, A and B, hold on Tyler, will change because they are not at 3, 4. C is at 3, 4. It will not change. Yes?
When you were here, I never looked at that. I could have done that.
Okay, you just...
When we got the score, I looked at it, and I was like,
Yeah, that's fine. And I said that too. And guys, they will give you questions like that. They will give you questions where they're immediately kind of freaking you out. Or they're giving you additional information. Remember, this test is to determine it's norm referenced, where you fall compared to others. Every single one of you is above average in math. Every single one of you should be getting an above average score. Just once again, how many of you get 5s versus how many of you get 4s means a lot more to me than it does to you. The only person in here who really means more to, I'll call her out, is Lola, because she just wants to tell Anna she did better than Anna did. Right, Lola? Pretty much, yeah. Okay. Yes, we're still recording, but now